In the motion programming for KUKA robot, there are 3 types of robot motion that can be achieved, which are point-to-point, PTP, linear, LIN, and circular, CIRC. For PTP motion, the tool is moved along the quickest path to an endpoint. For the LIN motion, the tool is guided at a defined velocity along a straight line. For the circ motion, the tool is guided at a defined velocity along a circular path. By using world coordinate system and from home position, the pen mounted on the KUKA robot is rotated to a position where it is perpendicular to the flat work table. The motion is created by pressing motion, PTP motion and press OK. Then, the pen is moved towards the first point of the contour on the work table, by using PTP motion. After that, a LIN motion is created from first point to the second point, at speed of 2 meters per second. After the linear motion, a circ motion is created from point 2 to point 3 to rotate the pen along the curved surface on the path contour, by ensuring its longitudinal axis always perpendicular to the path contour. The next circ motion from point 3 to point 4 is also repeated by using the same step. Then, LIN motion is created to move the pen along the straight line of path contour from point 4 to point 5. After that, circ motion is created again from point 5 to point 6 to move the pen on the return path of the contour. The step is repeated for another circ motion from point 6 to point 7. Once the pen is perpendicular to the flat work table, a LIN motion is created to move the pen from point 7 to point 8. Finally, the pen is moved back to point 1 by using LIN motion. The robot is then back to home position. After the robot is successfully programmed with the desired commands, the program can be checked by using step-by-step motions to ensure the programs have been inserted correctly. Besides that, this could help the operator to determine a line of programs that need to be corrected if the command is incorrect. After completed the motion programming and step-by-step checking, the program is then saved and run in auto mode. The robot motion is observed closely. After the program creation, the file is then duplicated and modified for approximate positioning during certain motion of the robot. During the approximate positioning, the robot does not move exactly to each programmed position, nor breaking the robot completely. This can help to reduce the wear and improved cycle times of the robot motion. The approximate positioning, CONT, is added to line 8 and line 12 of the commands, with the default approximate distance set. The example of adding approximate positioning is shown in the video. Then, the robot program is saved and run to observe its motion. Logic programming can be done also in the KUKA robot. The polling of the inputs and setting of outputs are used for communication between the robot controller and the periphery such as tools, sensors, etc. There are few types of logic commands can be selected, such as time-dependent and signal-dependent wait functions, switching function, coupling or decoupling an interbus segment. To implement the wait function, the commands is selected, followed by logic, and wait. Then, the wait time is specified for 5 seconds. Another signal-dependent wait function, wait for, is also added before the robot motion return to the home position, with the request for signal at input 12. After that, the program is saved and run to see the robot motion. Time distance function can be added to the program to trigger a certain function, such as closing or opening the weld gun during spot welding, switching the welding current on or off during arc welding, and starting or stopping the flow of adhesive in bonding or sealing applications. In this case, SIN-out is added after the linear motion to the first circular motion, by giving true state to the output 15, endpoint at start with delay of 30 milliseconds. Then another SIN-out is also added after the fourth circular motion before the linear motion, by giving full state to the output 15, endpoint at end with delay of -30 milliseconds. The program is saved and run to see the robot motion.